Okay, and welcome back, students who are taking Math for Business and Finance and Math Applications. And we are doing the Chapter 22 word problems. These are the optional problems, optional word problems that I'll be covering in this series of videos. It starts out with number 5, okay? And these are, conceptually speaking, these are a lot more difficult than even doing the standard deviation, because we're going to be talking about normal distribution. Okay, go back and watch the theory videos, and in order to understand the underlying concepts, remember you needed to know, you had to understand what the mean was, the median and mode, especially the mean, in order to be able to do standard deviation. If you didn't know how to do a mean, then you can't do the you're wrong. If you get the mean wrong, then standard deviation will be wrong, because mean is a part of standard deviation. And now we're moving from standard deviation into normal distribution. Okay, so if you don't get the standard deviation right, then you can't get the normal distribution right, right? So you have to have, even though the theory videos presented the concepts, everything builds one upon the other, and as far as the application is concerned. So in the previous videos, yeah, if you struggle with standard deviation, welcome to the group. Everybody struggles with it. And yeah, these next videos are going to be even a little bit more difficult, but hopefully I can explain it in a way that you'll be able to understand it. Okay? All right, so before I go any further, it's not something that you can ask about in an email. You'll have to telephone and speak with an instructor. Okay? Watch the videos again, because I think I'm able to explain it in a way that you'll be able to understand. But if you still don't, then you definitely need to telephone and speak with an instructor. And so now problem number 5 here says the mean useful life of a car battery is 48 months. Okay, so the mean is 48 months, and they have a standard deviation of 3. It says if the useful life of the battery is normally distributed, calculate the percent of the batteries with a useful life of less than 45 months, and B, the percent of batteries that will last longer than 54 months. Okay, so less than 45 and greater than 54. Okay. Now, to be able to understand this, we have to think about the normal distribution curve, right? Here's the curve, right? And it had said our mean is 48 months, okay? And the standard deviation is 3. So what does that mean? That means that for one, that's 3 months of standard deviation. It's not 3 standard deviations. So that means, remember, well, let me back up here a second. Remember, under this curve, everything under the curve is 100%. Okay, so if we have a mean of 48, that means from here to here is 50%, and from here to here is 50%. Okay, because that's the mean. Now, if you understand that there's 50% to the left of the mean and 50% to the right of the mean, okay, if I have a standard deviation of 3, that means 48, well, half of that is half of that, so I divide by 2, that gives me 24, okay? If I add 3 to that, that gives me 27, okay? So from here to here, in one standard deviation, that's 27. From here to here, that is minus 27, okay? If I take another 3, okay, that puts me to here, right? I'm sorry, let me get this right. 24, no, it's 21, I'm sorry, 21. I'm trying to figure out how to explain this. 21, that's 21. Because remember, underneath here, this is all, the entire part is 24, right? 50%, 24. So from here to here, this is 21, and this one here is 18. Okay, 18. There's the way to go. So from here to here is 21, and that's 18. So now, the problem is saying that if it has a useful life of less than 45 months, okay? So if it's less than 45 months, so 45 months would be someplace here, okay? Which means that I have my full 50% from this half of the curve, because we're talking about less than 45, right? So I have 50% of this portion of the curve, and 45 falls within the 1 standard deviation of the 34% portion of the curve. So if underneath the curve it's a complete 100%, I'm going to subtract out the 50% plus the 34%, okay? And that's going to give me 16% of batteries with a useful life of less than 45 months. Okay, now I'm erasing all of this, and I'm going to explain it again. My question says, my mean useful life of a battery is 48 months, and it has a standard deviation of 3. Okay, so if I have 48, I have a standard deviation of 3, that's going to be a plus 3 going in this direction for each deviation. So plus 3 plus another 3, so that's 1 full standard deviation, because this 3 represents the number of months. It's not a, so they have a 1 standard deviation. Maybe that's what I should write in there. They have a 1 standard deviation of 3. That would make this much easier to understand. So if I have 1 standard deviation is 3 months, all right, so I'm going to add 3 months, and then I'm going to add 3 more months to get 2 standard deviations. Okay, and then conversely, I'm going to go in the opposite direction. I'm going to subtract 3 months for 1 standard deviation, and I'm going to subtract another 3 months for a second standard deviation. Okay, now notice what I'm building here. Okay, I'm building the curve. So when I'm looking at it here, I have 48. Okay, and if I'm going to add 3, that gives me my 1 standard deviation. And if I add another 3, that gives me my 2 standard deviations. And I'm going in the opposite direction. If I add 3, if I'm subtracting 3, I'm subtracting 3, that's 1 standard deviation. And if I'm subtracting another 3, that's another 2 standard deviations. Okay? Now, remember, the mean falls in the middle here. Okay? And the problem had said we're looking at 45 months. Well, for the 45 months, we're looking at it falling right here. Okay? That's where 45 months ends up being. All right? Because it's saying a useful life of less than 45 months. Well, if it falls here within 1 standard deviation, that's 34%. Okay? But that's the less than side, okay? Or the negative side, okay? We have to take into consideration the positive side. Remember, underneath this curve, underneath the entire curve, that's 100%. So if I'm sitting here on the negative side, okay, that means, well, before I say I'm sitting on the negative side, that means to the left of the mean, we're talking about 50% is covered underneath this whole area right here, and 50% is on the positive side. That's covered underneath this whole area here, right? So if I'm sitting up here at 45, okay, that means I have 50% of here, because that's the positive side, right? And I have 34% on the left-hand side, right? Because it's within 1 standard deviation. So I add those two together, which gives me 86%. And since it's under the entire graph, that means all of this here, right, is 86%. This remaining amount is the 16%. Okay, so I hope you understood that, and that's for part A of this problem. Okay, so let me erase this. Pause the video, watch it again, scribble, but let me erase it, and we'll do part B. Yeah, this is yeah, it's mentally challenging. Okay, so here we are at the mean, 48, and for part B, it says the percent of batteries that will last longer than 54 months. Okay, well, where does 54 months fit in here? Now remember, this is 3, so we're up to 51 here for 1 standard deviation, right? That's 51. And for for 2 standard deviations, we're going to add another 3, which gives us 54, right? And it's saying for 54, so we're talking about 2 standard deviations. Now, remember, that's greater than this 48, so everything to the left here is 50%, okay? And we're covering it all the way up to this portion in time, okay? And in this portion in time, it's 34 plus an additional 13.5 because we're 2 standard deviations out. So I have 50% plus my 34% plus my 13.5%. And since we're trying to figure out what portion is underneath the entire curve, right, meaning we're looking at this portion right here, all the way down here, right to there, okay? Everything that's covered under here is 100% minus this, okay? So 100% minus 84 plus 13.5 is this total is 97.5%. So 100 minus 97.5% is 2.5% is the portion. That's this portion right here of the curve that's left over. Okay. And that's all there is to it. Okay, so if you kind of follow along with that, hopefully, those 2 examples will give you a better idea as to how to think through this. All right, sure, it seems like step by step, but again, it depends upon the variables, right? We're going to watch this video again. If you don't understand that, I think you will. Hopefully I explained it in a clear enough manner in order to be able to get it. This is how I'm thinking through my head. Okay, but when we go into the next video for number 6, we're going to be doing the same thing, and also for number 7. So hopefully by doing these 3 problems, we'll get a better understanding and be able to work through that information a little bit better. Okay, so I'm going to pause here and be sure to watch the next video.